I'm Natalie. I'm an engineer here at Gridspace, and today we are going to be talking about what is an embedding. What is an embedding? What is embedding? What's an embedding, Anthony?
How do we get words into the computer?
That's a great question. Typically, you need a word representation, or you need a way to represent the word. A first thought would be like to encode them in what we call a one-hot vector. You can imagine that for every word, we have a 1 if the word is present and a 0 if not. So then that'll just be a 1 for every one hot vector, or a vector with a 1, 1 and a bunch of zeros. But you can imagine if our lexicon is huge, like 40,000 words or something like that, you're going to have a lot of sparsity, right? And your matrix multiplication is going to become intractable like pretty much immediately. So what do we do about that? What we want to do is create dense representations of words using what we call an embedding. Essentially what that means is that a word is transformed in some way to a vector representation of it that's very dense, meaning it's primarily all filled out. It's not sparse in that it doesn't have a lot of zeros. Because you can imagine in the vector space, right, you pretty much have one vector in each direction for every single direction when you have a one-hot encoding. But in this space, in an embedding space, in an embeddings vector space, all of the vectors are going to be way closer together and far more easily differentiable. Calculus and multivariable calculus, which is used a lot in machine learning, you want the vector space to be smooth and easy to work with, and that's accomplished using an embedding or a dense embedding space. What are some cool aspects of embeddings? If you can imagine, it kind of makes a lot of sense to have them mean something in their space, like they're not assigned random values for each word. Say you want to predict the word happy versus joyful, you would assume that those two vectors are in similar spaces, right? Or are kind of close to each other, versus happy and sad might be opposite vectors, kind of pointed like that. So you can perform really fast searching using embeddings because you can look for, this sounds dumb, but you can do things faster with numbers as opposed to words. Thanks for watching. Please like and subscribe if you liked this video and to get more of our content. If you have any other terms you want us to define, put them in the comments. And if you want to know what we're doing at Gridspace, check out gridspace.com.